Okay guys, welcome to Superstition Bro, and this is part 2. And I'm gonna explain you the what is Venus, because earlier I explained you Mercury. Okay, let's see. We are also done about the days and nights and afternoons. Okay, we had Jupiter, Earth, Mars. Who's this? Okay. Okay. I'm gonna explain you. Okay. Let's go to Venus. Okay. Wow. Let's see. This is the pressure of Venus. Oh, Sun is also doing that to Venus. Wow. Okay. Okay. So let's see what are we gonna do to Venus. Okay. Wow. Currently, we have little direct information about the internal structure of Venus. However, its similar size and density to Earth suggests that they share a common internal structure. The principal difference between the two planets is the lack of plant tectonics of the on Venus, likely due to the dry surface and mantle. This result are the reduced heat lost from the planet, preventing it from cooling and providing a likely explanation for its lack of an internal of an internally generated magnetic field. Instead, Venus may lose its international heat in periodic major resurfacing events. Okay. Wow, Venus has the most hottest like volcano. Wow. Then she got the lava of the most hottest one than volcano. Okay. This is her lava. This is the part that Venus delivered to Earth, like the planet. Okay. So this is the sun. We can also see stars. Okay, next is okay. Let's go back. We're gonna explore. We're gonna explore Earth. Okay, this is Earth. Earth crushed together of wow, it's just the same. Earth's crust together with the uppermost parts of the mantle. Of the mantle forms the lithosphere. The lithosphere is broken into a series of tectonic plates with float. On a more elastic part of the upper mantle, the motion of these plates gives rise to earthquakes and volcanoes. The Earth's mantle is rocky shell, which accounts for 84% of the planet's volume. The uppermost regions of the mantle are the most solid and are relatively rigid. Okay. Earth has a lot of earthquake. This is how earthquake pops because of this. It's like while we have earthquake, Earth is having tsunami from Pacific Ocean, Drake Passage, anything more. So this is where earthquakes come from. When it popped out, the earthquake will break all of the lands. Will break the land and the grounds. Okay. Now the when it's suddenly getting full and go up, it's like a volcano just splash like a grenade. Okay. Sun is also facing to the earth. And today, where's Philippines? Philippines. Okay. Sun is also facing to earth. Okay, let's go back to the solar system. The next one is Mars. Okay, wow. Looks good. Whee! I want to spin you. Whee! I like spinning. Okay. Structure. Wow. It's just healthy, but I don't know. Okay. The outer crust is rich in... Whoa! Mars is also rich by this gold. Okay. This looks brilliant. Okay. The outer crust is rich in silicon, oxygen, iron, magnesium, aluminium, calcium, and potassium. All of which could be used in development of future human outposts on Mars. Silicate mantle was once very active, giving rise to many of the planet's distinctive surface features, but which now appears by dormant. Like Earth, Mars has undergone differentiation, resulting in a dense core, primarily comprising iron and nickel, but with around 70% sulfur, which renders the core partially with liquid. Wow. So Mars has she has 17% sulfur. Okay. Now, that's her oxygen. Okay. She has oxygen, silicon. She has silicon, oxygen, 17% sulfur. Okay. That's all. Wow. And also, Sun is also facing to her. Look. Okay. Let's go to the solar system. We're gonna talk about Jupiter. Okay, let's see. Whoa, there's a little moon inside. Okay. Jupiter is the compost primarily of the gaseous and liquid matter. There are no surface of gradual change from the atmosphere. Conditions blend smoothly from the gas, the liquid as temperature and pressure inside Jupiter increase steadily toward the core. The surrounding liquid hydrogen is responsible. Jupiter's massive magnetic field, with 10 times stronger than Earth, with the magnetic pole strength being near 20,000 times stronger than Earth's pole strength. Jupiter is thought of a dense core. That exactly composition of the core is unknown, as are the properties of materials at the temperatures and pressures of the depths, but it is thought to be solid. Wow! So Jupiter, he's so very big. He's 10 times stronger than Earth, but he's the most disgusting and smelly Jupiter. Yeah, he's so disgusting smelly at all. Okay, he's so smelly and disgusting. He's smelly, disgusting, yeah. Okay, but it's beautiful, the design. Next one we're gonna talk about. Saturn. Let's talk about Saturn. Wow. Wow, look at her. Saturn looks so pretty. It's just like a ring and she's so pretty. Okay. Saturn's interior is similar to Jupiter's, contrary Jupiter's Saturn. Saturn's destiny is lower, making it does least dense planet in the solar system. Combined with its rapid rotation, Saturn became the most oblate planet in our solar system. Its equatorial and polar diameters vary by almost 10%. Due to the lower gravity, Saturn's atmosphere has the more haze than Jupiter's, with blurred features and colors muted in a general yellowish hue. The winds on Saturn are 5 times as fast as those measured on Jupiter. Saturn radiates 2.5 times more than heat it receives from the sun, possibly due to the raining out of the helium deep into its interior, creating frictional heat. As the helium descends through the lower density hydrogen. Wow, so Saturn is the very coldest planet. She's so cold. Wow, and she has a spinning ring and it's so very pretty. Okay. Let's go to the solar system. Next one we're gonna talk about is Uranus. Wow. Wait, what? He's just like Saturn, but he's upside down. Okay. Okay. Okay, let's go back to him. Let's go back to Uranus. Okay. No. Wait, I didn't exit. What was that? What was really that? That was weird. Okay, guys. We're back, by the way. Okay, there we go. Okay, come on. Okay, so let's go back to Uranus. Wow. Wait, what are these? Wow. Wow. Okay. Okay. Wow, he's so cold. He has the most golden eyes. Okay. Uranus' cyan color is due to the absorption of red